Okay, so last video for section 2.8. So we saw how to figure out whether two functions are inverses of each other, and also we saw an example where graph is given to how to sketch the graph of the inverse function. And now we want to see how can we find the inverse function if we are given a equation of a function. So if the function is given in terms of an equation, how can we find the inverse function? Well, remember, inverse function will exist only if the given function is one-to-one. Okay? So how do we do this? We replace, this is the first step. These are the 4 steps, very common, traditional. So this is how we do it. So the first step is to replace f of x by y. So sometimes the equation will be given as f of x is equal to something, or it could be given as y equal to something. So if it is given as y equal to, for example, here, instead of f of x is equal to x cubed plus 4, if you are given y is equal to x cubed plus 4, then you skip the first step. It's already there. The second step is interchange x and y, because remember I have been saying from the beginning, the inverse function, the role of x and y get interchanged. So that is one step we have to do, interchange x and y. And then we now solve for y in terms of x. So remember, our function is given here as where we have y in terms of x, right? But now we interchange, and now again we find y in terms of x, because that's how we represent any function. Once we have done this, and this involves algebra. Okay, this is kind of the crucial step which involves the algebra. Once we are done with this, so there shouldn't be any y on the right hand side. On the right hand side only numbers and the variable x. So then we will replace the y by f inverse of x. So that's what our inverse function is. So let's try these examples. So in this one, the first step I have shown is the replacing the f of x by y. And then what is the next step? I interchange x and y. So y will be replaced by x, and the x is replaced by y. So x equals y cube plus 4. So now I want to find y. So what will I do? I have to first isolate the term which has y in it, which means I will subtract the 4. So this will give me x minus 4 equals y to the third. And now what do I do? I cube root, take the cube root on both sides. So I get cube root of x minus y x minus 4 equals y. And that is our function, because now I will replace the y by f inverse of y. So this gives me f inverse of x equals cube root of x minus 4. And if you go to previous example up there, see these are the same function that we have there. Now the second part, B part, again this is something you can do orally, like you can directly write f inverse of x by saying, okay, in this one, as I showed you earlier, x is being multiplied by 5 and then 3 is being subtracted. So when we do the inverse of or the opposite of or reverse of subtracting is adding. So you can say f inverse will be x minus 3 over 5. But I would rather that you do it by using those 4 steps so that you get used to using them. So let's do them by that method. So I will replace f of x by y. So we'll get y is equal to f of 5x minus 3. Then we will interchange x and y, right? So it's right, y is equal to 5x minus 3. The next step is that x equals 5y minus 3. Now I have to find y. So first thing I do, add 3. So I get x plus 3 equals 5y. And now divide by 5. So we get y is equal to x plus 3 whole divided by 5. And so this is f of inverse of x. So this is f inverse of x. Or you can write it separately, that f inverse of x is equal to, by the way, let's check the name of the function. Was it f or was it g? Okay, I named them all same because you could have different names, so accordingly you will have the inverse function. So that is your f inverse of x. Now the algebra in these two problems were not that bad, but next problem is something which you will often see, and whose inverse you will have to find, and this is how you do it. So I will start again by writing y in place of the function name, which is in this case is also f of x. So I will start by saying y equals 2x plus 1. Divided by x minus 5. And next step is to interchange x and y. So if you want, you can write it like steps. Number 2, x equals 2y plus 1 divided by y minus 5. And here comes the algebra related to this. I actually want to move this over here. Okay, so step 3 is I will cross multiply. See, here we can do the cross multiplication because there is an equation here. So we cross multiply, okay? And sometimes it will happen that you might have some, extra things there. So you still cross multiply. So x times y minus 5 equals 2y plus 1. Okay, so now in order to find y, notice here that y is on both sides of the equation. So y term is present on the left hand side and on the right hand side. So we have to get all those terms together. So how can we do that? Well, we cannot do it like directly from here. We have to do one more step, which is distribute. That is an important step here, distribute. So the first kind of step was to replace x and y. So whenever you have these fractions, if your function is a rational function, so this is a rational function. So in that case, this process you have to remember. So first step is to change f of x to y. The second step is interchange x and y. Third step is cross multiply. Maybe you should write those separately. So with a rational function, this is how it will go. So you will have to cross multiply and then you have to distribute. So distribute xy minus 5x equals 2y plus 1. Okay. So if I write the steps, what did I do here? Cross multiply. Or should I say that in the previous with the, yeah, I should say it over here. After this, cross multiply. And then once you have cross multiplied, the next step to do is distribute. Okay, so then what do we do next? Then we bring the y terms on one side and the rest of the terms on one other side. So you can see we have 2y here and we have xy here. So it doesn't matter whether you take the y terms to the right or to the left. I'm going to move them to the left. So I get x times y minus 2y equals 1 plus 5x. Okay. So after this step, now you see on the left hand side we have two y terms. So what do? We factor out y. So that is the next step, factor out y. And always when with a rational function, this is what will happen. Factor out y. So we get y times x minus 2 equals 1 plus 5x. And the last step kind of that we divide by x minus 2. So this is your f inverse of x. Okay, now can you see this would have been really hard if we wanted to do it directly like we did the previous two programs. So these are the steps that you have to remember in when you the rational function, when you find the inverse function. So the steps go a little bit more than we have written here. So if you can remember the algebra or you can remember those steps, that's all you need to do. Okay, last couple of examples, and these are actually the type of examples you will see in the exams or in the final exam when you check it. So you're given two functions here in example 6. So you're given two functions, you are asked to find different things. In the first case, first part, we have to find the composition of the function P of M at 6. Now, in order to do this, you don't have to actually find the function which is mentioned here. You can actually directly do the calculations by plugging in the values if you understand what the question is asking you. Okay. So we have a function by the name M, and then we have a function by the name P. So finally, strange names. We haven't seen these names before, but that doesn't mean that they cannot exist. So we have where did it go? Okay. So we have the function P and the function M. Okay. So the question is asking us to find this quantity. Now to find this quantity, you should try to find the numerator separately and then the denominator and then put them together. So I will do it by finding P composed with M of 6. And as I said, this can be done by first finding the function P composed with M and then plugging 6 in that, or we can do it directly because we should know that P composed with M of X will be P of M of X. So this will now be P of M of 6. So which means P of what? So what is M of 6? You will plug in 6 in M. So what do we get? So M of 6 will be square root of 9, which is 3. So you can directly do that actually, or you can write it over here. So there will be 6 plus 3, which is 6 P of 3. Okay. So which is equal to P of 3 plus P of square root of 9, which is, again, if you want to do step, that's fine. So this will be P of 3, and now I will plug this 3 in the P function. So it will give me 9 minus 5, which is 4. So this is the top. Now we do the bottom. So which is P minus M of 1. So what is this? This is the subtraction of the functions which you saw in 2.7. So this will now be equal to, by definition, it's P of 1 minus M of 1. Okay, so what is P of 1? Well, that will be 1 minus 5, so it will be negative 4. And then minus M of 1. So M of 1 will be 2. Square root of 4, which is 2. So we end up getting a negative 6. So the final answer will be, this quantity will be what? 4 over negative 6, or negative 2/3. So that is the final answer. P part now is saying find M inverse of 2. Again, you can find M inverse and then plug in your 2 in there, or you can do it in another way. So remember, when if I ask you to find m of 2, what you do, you plug in this 2 for x. So this 2 here is the x value, right? But this m inverse of anything, m inverse of 2 is the y value. I mean, the 2 in here is the y value, because m inverse, remember, gets applied to the y. So this is y. So what m inverse 2 means, y is equal to 2. So you can, in your function m, in place of m of x, you can put 2 and solve for x. Okay. Don't get mixed up the separation. So which implies I will take the square of both sides. So 4 is equal to x plus 3. So x will be equal to 4 minus 3 is equal to 1. So which means m inverse of 2 is equal to 1. Okay. The last example here. Similarly, now you are given to function. Now there could be more, questions asked here. If you notice in the first example 6, we are seeing only numbers here, but you could be asked what is m composed with p of x, which is actually not 2.8 but 2.7. Okay? And then g composed with p. Now could you find p inverse of p? No. Why? Because in p function is not 1 to 1, so we cannot have p inverse. But m is 1 to 1, so that's why we could have m inverse. Okay, last example here. So g of 1 divided by composition. So again, as I mentioned earlier, you can find the composition and then plug in, or we can directly do it. So let's do it directly. So m composed with, g composed with f of 2 is equal to g of f of 2. Again, now if you want, you can separately find what is f of 2 and then bring it over here, or you can do it directly. So it will be g of, so what do? I plug in 2 in f. So I'm going to just write it there. So I get 2 square plus 4 into 2 minus 13, which is equal to g of 4 plus 4 is 8. 4 plus 8 is 12 and minus 13. So I get negative 1. So g of negative 1, now I plug the negative 1 in the g function. So I get 1 plus 5 over negative 8. So I'm getting negative 6 over 8, which is negative 3 over 4. But that is not our final answer, remember? So now I have to find g of 1. So g of 1 will be 1 minus 5 over 8. So it will be negative 4 over 8, or negative 1 half. So that now this quantity will be negative 1 half divided by negative 3/4. So simplify, what will we get? 2/3. So that will be the final answer. Now in this one, it's asking you to find the g of x, g inverse of x, not like at a number, but in general. So what is the g function? It is, so I will start by replacing the g of x by y. So I get y minus is equal to 1 minus 5x over 8x. And then next step, we interchange x and y. So it becomes x equals 1 minus 5y divided by 8y. What do we do next? We cross multiply. So we get 8xy equals 1 minus 5y. Now bring the y terms on one side. So we end up getting 8xy plus 5y equals 1. Which means we've now factored out the y. We are left with 8x plus 5 equals 1. So kind of last step or second last, we get the y. So y is equal to 1 over 8x plus 5, which means f g inverse of x is equal to 1 over 8x plus 5. So that is your inverse function. Okay, so that's it for section 2.8.